Throughout your experience in math, you're going to encounter functions in 5 different ways. These are the 5 different ways you'll encounter functions all the way up through college. We are going to convert between a graph and a table and graph. It's very important to be able to manipulate between these different function types. Okay? So for -2, we're just going to look at our x values. We'll look on our graph and see where we see them. So for -2, our graph comes all the way down to about -4. For here, at 0, our graph comes down to all the way about -6.5. For 3, our graph goes up to about 2.5. For 4, our graph goes all the way up to about 4. For 6, our graph goes all the way up to about 5. And for 7, our graph goes all the way down and stays around 0. We are going to now convert for a table to a graph. And the way we're going to do that is using coordinates. This is -2, -4, then -1, 0, 0, 3, 1, 0, 2, -4, and 3, -8, just plotting points. And normally you wouldn't do this, but I designed the graph so you could. You connect the dots to make your new graph. And there we go. We're going to try to create a table and a graph from a representation of an equation. Before we do that though, we have to take this equation and evaluate it for these different values in the table. We're going to do that on the board. When evaluating, the big thing you gotta look for is the signs. Pay attention to the signs. So for me, when I'm trying to do this, I make sure that I put parentheses around my numbers when I'm plugging them in. So let's kind of go through the step by step, and we'll see where our values are. So I plug in first -2, use parentheses. Okay, I know that -2 squared is a +4, but the negative's outside of it, so therefore I can just change the sign to -4. Here, absolute value makes any number positive. -2 becomes +2. And this is actually 0. We're going to do the same process for the other numbers. So for -1, plug it in. Do -1 squared. I get +1. Absolute value makes a positive. Combine like terms. I get 2. For over here, we're going to do -1/2. Plug it in. That's what we get so far. When we square -1/2, it becomes 1/4. This becomes positive. Be careful here when we're combining like terms. So this is really -1/2 or 1/4 plus 2/4 plus 2, which is really 2.25 or 2 1/4. Now let's plug in some more values. These ones we don't have to be as careful with. We still should be careful with, but we have these ones were hard to get the signs. Be careful of the signs. We're going to plug in 0. 0 squared. Absolute value 0. 0 squared is just 0, and you can't really take negative 0, so it's 0. Absolute value is 0. This is just 2. Here we plug in 1/2. One half is just squared is 1/4, but it becomes negative because of the negative outside. Absolute value of 1/2 is 2. We combine all of our stuff together and we get 2.25, or 2 1/4. For 1, we plug it in. One squared is 1. Then it becomes just a negative 1. Absolute value of 1 is 1. Combine like terms. I get 2. All right, so we got one more value to do. We're gonna plug in 2. So it becomes 2 negative 2 squared plus absolute value of 2 plus 2. This becomes negative 4 because 2 squared is positive 4, but this negative sign makes it negative. Absolute value of any number is positive. Add combine like terms, you get 0. So now we're ready to take these values and fill in our table. So our table values are 0, 2, 2.25, 2, 2.25, 2, and 0. Let's go ahead and try to graph it. So our points become negative 2, 0, negative 1, 2, negative 1/2, 2.25, 0, 2, 1, 2.25, 2, 1, 2, and then 2, 0. So we kind of connect our dots into this kind of shape. And there we go. Let's use our different representations and function notation to analyze some multiple representations of functions. So we have a graph. So this is referring in our function notation to an x value. So when our x is 3.5, what is our y value? Well, our y value is 2.5. For here, this is referring to, so if f of x is equal to 2, we're trying to find our x value because this is giving us a y value. Well, when y is 2, we have two different options, it looks like here. We could have x could be 2, or x could be negative 2. So over here, again, we were looking at y values. When y is 3, x could be negative 3, or it could be positive 3. Now let's look at this. When x is negative 3, what's our y value on a table? Well, it's negative 1/3. What about when x is 0? When x is 0, oh, it's undefined. So we're trying to look at our different parts of the table to make some comparisons. Here, this is referring to y value. So one is our y1. So we got to look at the f of x column. When our y is 1, our x is also 1. So x is 1. Now let's look at an equation. So the equation is going to require for us to actually evaluate some of these values to figure it out. So we're going to have to evaluate negative 2. So I substitute. Negative 2 squared becomes a positive 4. 4 times 2 is 8. 8 minus 5 is 3. So f of negative 2 is 3. We're going to do the same thing here with 0. We're going to substitute it in. F of 0 equals 2 times 0 squared minus 5. 0 squared is 0. 2 times 0 is 0. And 0 minus 5 is negative 5. So f of 0 is negative 5. Let's keep it going. Now we're going to substitute in 1. F of 1 is equal to 2 times 1 squared minus 5. 1 squared is 1. 2 times 1 is 2. And 2 minus 5 is negative 3. So our f of 1 is negative 3. For multiple representations of functions, the key idea here is to be able to go between tables to graphs or graphs to tables and then be able to create a table or a graph based off of an equation. When we go on to later topics, that's where you'll be able to create equations from the graphs or the table.